Here's a different example of maximum minimum calculations that I could use with profile of a surface. This part here is a part that the machine tool students make as a final project, and it's got some GD&T on it, and specifically it's got profile of a surface. It's got a couple of them. There's one here and there's one here. This profile of the surface callout has two frames, and they're each done independently, but I'll show you what the second frame means, and it's really not anything that's it's complex or anything. It's a fairly simplistic idea. It just kind of looks a little a bit confusing. But this profile of the surface of this this feature here is all around, which means that anything that contacts this surface, which the leader line points to, is included in this feature control frame for the profile of a surface. And what I want to do here is I want to calculate and find out what the maximum distance is from here to here that I can measure and still be good, and the minimum distance I can measure from here to here and still be good, the maximum distance I can measure from this surface here to this surface here and be good, and the minimum distance between this surface here and this surface here and be good. And this is just an example. But the distance from this edge here and this edge over here is 3.25 minus 0.25. So if you look at it like this, you'll see that this 3.25 dimension here from here, that's not the dimension from here to here, it's 3.25 from here to here, but from here to here, from this edge here to this edge here, it's 0.25, which is right here. So you can see, you got to do a little bit of math. So this overall distance from here to here, using the basic dimension, is 3 inches. And the distance from the bottom here to these two surfaces up here, which is actually the one surface because it's contiguous, is 2.25 minus 0.25, which is 2 inches. So from here to here, the basic dimension would be 2 inches. From here to here, the perfect dimension would be 3 inches. So what is the maximum and minimum calculation I can use? Well, if you look here at the feature control frame, we've got profile of a surface is 20 thousandths, which is 10 up and 10 down. With this datum reference frame, which is A, which is the top surface here, E, which is this datum here, which is the bottom, actually the bottom out surface down here, and then D, which is this surface here. So we have to get 3 points on that plane, 2 points on this plane, and then 1 point on that plane right there. And that locks our part down. It can't rotate, it can't rock, it can't go up and down, or it can't go side to side. And so that says that with it locked in there, I've got 10 this way, 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 and 10 this way. And these are all in inches. Okay, so the maximum I can have this way and this way is going to be a little bit. It's going to be it's going to be 10 thousandths this way and 10 thousandths this way. But if I look at this bottom one here, this only has reference to A and E, which means that we no longer use D, which is this surface here, to lock it down. And D is a point here on this surface, any point on that surface, to move it, to stop it moving back and forth this way. So it can move back and forth this way by the 20 thousandths, but in this direction, this way and this way, since it's not locked here, and it only goes from A to E, and E is down here, okay, that means that in this direction, in the E direction, it's locked down with 2 points here, okay? It can't go up and down. So it says that I further restrain this thing from going up this way and down this way to a 6 thousandths profile of a surface tolerance. So let's look at the max min for this distance here. Well, I notice it's locked down on all three axes here, basically. datum A, which is the top surface here, datum E, which is the surface down here, and datum D, which is this surface. So it can't go this way, it can't go this way, and it can't spin, it can't rock, so it's locked down. And it says that in a lockdown state, it'll let me go 10 this way and 10 this way. So basically I just take that 3 inches and add 20, and take that 3 inches and subtract 20. Because it could be 3 inches plus 10 this side plus 10 this side, which is 3 inches 20 thousandths, and it could be 3 inches minus 10 and 3 inches minus 10, which would be 2 inches 980 thousandths. So the maximum will be 3 inches 20 thousandths. The minimum will be 2 inches 980 thousandths. So if I take my calipers, and here's an actual part here, if I take my calipers and measure my part, this distance here, which it shows on the calipers there, and I don't know if you can see that or not, but it shows exactly just a little over, actually right about, just a little half thousandth or so over 3 inches. So I'd have that much to that much. So anywhere in that range is a good part, 20 thousandths. Okay. So if I look at this direction here and I want to measure this one from here to here, okay, I know my perfect dimension's 2 inches. Well, this measures perfect right now, if you can see that. So I don't have to worry about it. But let's look at what the minimum and maximum on this are, because they're not the same. It's not the same in this direction as it is in this direction because of the feature control frame. Because now we're locked down in E here, so it can go back and forth. So that 20 is still good, but since it can go back and forth, I'm only looking for the profile in this direction. So it must fit into something this way. It doesn't matter where it is this way as long as it fits this way. Because now we're looking at a profile of a surface tolerance of 3 thousandths, which is 3 this way and 3 this way. So my maximum would be 2 plus 6 and 2 minus 6, because I can have 2 inches plus 3 that way and 2 inches plus 3 that way. So the maximum will be 2 inches 6 thousandths. The minimum is 2 inches minus 3 thousandths and minus 3 thousandths, which would be 1 inch 994 thousandths. So if I measure my part again here, this dimension right here needs to be between 1 inch 994 thousandths and 2 inches 6 thousandths. And luckily it's just a little below the mean, or a little below what the perfect dimension would be, which is 2 inches.